Welder Qualification Explained. Gary Pace, PE, CWI. Acknowledgements. Just going to post this one here for a couple minutes so you can look at it. This is where I poach a lot of my material from. It's, Nuclear Regulatory Commission, all that. So if you want some good material on the cheap, or you want to make your own slideshows for in-house training, or throw some stuff on YouTube, this is a good place to get a lot of the material. Free, and it's put together by pretty sharp people. As we start diving into this, there's basically three documents that we really need to talk about. And welding procedure specification is a WPS. That's the recipe that welders use. A procedure qualification record is a document that shows what we did on our science experiment, and then that backs up our recipe, our WPS. And then we have our welding performance qualification paperwork. This is people. We're qualifying people at this point in time. So that's what we're going to talk about in this module, podcast, YouTube presentation. I don't know what this media is. But we're going to talk about welding performance qualification, WPQs. Welder qualification. Primary purpose for performance qualification is to verify the ability of an individual to execute a qualified welding procedure specification to produce a sound weld. Welders can be qualified by visual examination and destructive testing or radiographic testing. Welders qualify to specific welding processes, not welding procedures. All variables are essential, and machine welding is considered a different welding process. So when you're dealing with, when it says all variables are essential, it's saying that those that are listed are essential. For Section 9, ASME Section 9, you have for procedure qualification, you have essential variables, supplementary essentials, and non-essential variables. For welder qualification, everything is just an essential variable. So, but this gets back to, you're not qualifying to a specific welding procedure, you're qualifying to a process. Let's say flux core arc welding, and you're qualifying to make sure that you can deposit, the welder, can deposit sound weld metal. That's the gist of welder qualification. The need for weld qualification. Many variables influence weld quality related to the parts to be joined, the welding process, and the welding operator skill. The purpose of qualification is to demonstrate that welding procedures and personnel are adequately controlled and capable of producing acceptable results. Such tests cannot foretell performance in production. Quality of the production weld should be determined by inspection during and after actual welding. So here's some codes and standards. The application of codes and standards that specify qualification requirements for welding include ASME boiler and pressure vessel codes, AWS D1.1 structural welding code, ANSI B31 power piping codes. You've got 31.1, 31.3, 31 whatever, and you've got API 1104 standard for welding pipelines and related facilities. This is just 4 general directions you can go. Each one of these has a specific direction or set of criteria for their qualification processes. They're all generally the same, but there's some specific nuances that go with each one of these. Also, you've got the standard for weld qualification, AWS B2.1 welding procedure and performance qualification. That's an overall document put out by the AWS that covers, the general qualification of welding procedures and of welders. Welder performance qualification is a test administered to a welder to determine the welder's capacity to perform a specific welding application. Welder certification is based on specially designed tests to determine a welder's skill and ability to deposit sound weld metal. This involves limited tests such as visual inspection, radiographic, ultrasonic, magnetic, and liquid dye penetrant testing, followed by appropriate mechanical tests such as transverse bends, macro examination or a macro test, weld fracture test, nick break test, fillet break test, corrosion resistant tests, and ferrite number tests. Once again, depends on the code, the customer requirements, and what you need to get done and what their criteria are for production. So generally, for the most part, ASME Section 9 and AWS D1.1, the welder's just going to do make a coupon, weld out a coupon. You're going to do some bend tests, and you're going to do a visual test. Visuals first, and then you're going to do the bend, or you're just going to do an x-ray. But there could be something extra in there that you need to get accomplished, or if it's a fillet break test, it's a fillet weld test that you're giving the welders, then you're going to do a fillet weld break test. But the bottom line is welder skill and ability to deposit sound weld metal. Welder skill and ability to deposit sound weld metal is really what we're getting at. Terms and definitions. Welder Performance Qualification Test is a WPQ. It's a test given to a welder for the purpose of demonstrating the ability to make sound welds and meet prescribed standards. WPQ record is the record of a welder qualification test that includes the process, essential variables, types of test results, and range qualified. That's the piece of paper that's going to be in a filing cabinet somewhere or scanned into a computer that keeps track of what happened on that test. Usually you don't keep track of failed tests, but you could if you needed to. Okay, when we're talking about qualification of welders and then WPSs and PQRs, there's a wall. Don't confuse the two sides of the wall. Because I stole this from Walt Spurko, who's the chairman of ASME Section 9. He gave me his blessings. I told him I was going to borrow his material, and he was good with it. You've got a wall. You got procedures on one side and personnel on another. And a lot of people get focused in, well, my welder isn't qualified to that procedure. I qualified him to another procedure. No, welders generally don't qualify to a specific procedure. You qualify to a specific process and a specific filler material. You don't qualify generally, he can only weld with this procedure. Because then you'd get bogged down in a paperwork nightmare, right? Imagine how much trouble it would be to try and produce welders that were qualified to hundreds of different welder WPSs. Company I worked for, we had dozens and dozens of welding procedures for 7018 alone. And they were all written for different customers, and there was all kinds of craziness on it. But our welders, you give them one test, and they're covered for all that stuff. Because there's only 5 or 6 essential variables in a welder when you qualify a welder. Whereas a procedure in a PQR, there can be any number of essential variables and non-essential variables. So you got to get back to this wall. You got to keep the personnel qualifications on one side, the welder quals on one side, and the procedures and the PQRs on the other, and you don't crisscross these. Welder qualification. It's the range of approval is not as restrictive for welder qualification as for procedure testing. Welder qualification has fewer essential variables than procedure qualification testing. One welder performance qualification can cover many WPSs. Here's a welder performance qualification record from Fred's Welding. You can see that it's a pretty trimmed down version of some of the other documentation we've used. There's only a half a dozen, like we said, essential variables that you need to address, and there's a section down there where you write down the results and, you know, did he pass the bend tests, and maybe you had a macro etch or something else, but you write that in there. And then there's also, what's the organization, Fred's Welding, and then the welding engineer and the date. Or doesn't have to be a welding engineer. Who's the responsible party? Fred's just had a welding engineer, so that's why they've got that written in that spot on the form. But you can see this is the documentation used to keep track of welder qualification. So once you do this, you put it in the welder's file, maybe make a PDF file and put it on the internet within your company, so if other people need to access that information, they can access the PDF without rummaging through your file system. But this is one of the components that makes a good welding program work, is welder qualification and documentation of what the guy is qualified to do. Welder qualification. Here's the essential variables for welder qualification. And you can see there's only, one's for gas metal arc welding and one's for gas tungsten arc welding. There's only half a dozen welder qualification essential variables. Remember when we were talking about essential variables for procedure qualifications for WPSs? Remember how big that laundry list of essential variables were? For welder qualification, it's just half a dozen. You've got, is the guy using backing, base metals, pipe diameter, filler materials, what positions he using, is he going up and down in his positions, what's his vertical mode of travel, is he going vertical up or vertical down, do we have inert backing when we're welding, backing gas, and the polarity if we're on gas tungsten. And it's pretty similar for the one on the right, which is gas metal arc welding. Transfer mode, inert backing, position, if we're going up or down in the vertical position, filler metals, what's the F number, etc. P numbers for material, base materials, etc. So welder qualification essential variables are it's a way smaller list than when you're qualifying a procedure. And this gives you a lot more leeway to use welders on different welding procedures. Like we said, welders don't qualify to a specific procedure, they qualify to a process. So here's I guess I took the essential variables from ASME Section 9 and just kind of broke it down. Here's what you got to worry about with welder qualification. Welding process, base metal composition group. Okay, what are we welding? Is it aluminum? Is it carbon steel? Is it titanium? What are we welding? The thickness, the welding position. This is a biggie. This is where you can get in a lot of trouble, is welding position. Qualified my welders for horizontal. They've been welding uphill and overhead, and good Lord, we don't have any qualification paper on them for being able to run in that position. The base metal form, is it sheet, is it tube? Sometimes this is something that comes into play. A lot of times it is, because you'll have a guy, he might be qualified to weld, let's say 70-18 on plate, and then you need him to weld on a really small piece of sheet or tube, or a really small diameter piece of tubing. Well, you got to look in the code. Is this guy qualified or isn't he? So just because a guy is qualified to run in one form, flat, plate, whatever, doesn't mean he's qualified to weld in the same code with, if that material's a tube. Type of groove weld. Is it a groove or a fillet? Fillet welders, you qualify a guy with fillet welds, he's not qualified to weld on grooves. Groove welds, they can qualify, they're good with grooves and fillets for ASME Section 9. With or without backing. Is my groove an open root or is it not? Do I have backing? Do I have a backing ring, a backing strip, some form of backing on that weld? Or am I just going to weld it and then back grind it out and put in backing and call it good? And then there's a couple other welding conditions in there. Maybe, it's with a shielding gas or whatever. Depends on which code and customer requirements and all that. But basically, when you're qualifying a welder, these are the things you're worried about. When you're qualifying a procedure, there's 20 different things that you need to address. Generally, for welder qualification, this is it. You qualify to these, you look at your essential variables, you're good. And that qualifies a guy to weld on any number of different using welding procedures as long as they have they meet these criteria, these essential variables. Welder performance qualification. The performance qualification tests are intended to determine the ability of welders to make sound welds. A welder is qualified by radiography of a test coupon. A lot of times they'll just shoot it. You make the weld and then they're going to shoot it with x-rays, look at the film. Yep, he's good to go. Or let's say I got a super hot shot welder that I worked with for years and I hire him and I'm like, all right, this is my guy. I'm not going to test him. We'll just do the initial production welds. So we can bring him in, have him do a few production welds, x-ray him, and we're good to go. That's a little more risky because unless you know the guy and you know that he walks on water or he's super qualified, you're kind of rolling the dice there. And other times it's just visual and you're going to take some bend tests. Here's kind of a little variant of, you're going to look in. They're going to cut out a face bend and a root bend out of this thin material and cut it, slice it, and call it good. And you're going to look at the bends and the bend test samples, and if it's good, the guy passes. If not, he didn't pass the weld test. So here's QW 42052.1 test specimens. This is out of ASME Section 9, but you can see here it tells you, if it's less than 3/8 of an inch, you're going to do a face and a root bend. If it's 3/4 of an inch and over, you're going to do 2 side bends. And from 3/8 to less than 3/4, you've got a couple of different options there. You got to check your notes, but you're just generally going to do some side bends. The reason is you get over about 3/8 of an inch, and you can't do a face bend or a root bend. It's just way too thick a material. So that's why you do a side bend thicker than that. Visual examination, the weld should show complete penetration and fusion. The bend test acceptance criteria, no open discontinuities in the weld or HAZ greater than 1/8 of an inch. That's general for most weld codes. There's going to be some subtle differences. ASME Section 9 and AWS D1.1, there's a couple of subtle differences on the acceptance criteria and how they're measured in regards to openings, when something opens up. But that's the general gist of it, is most of these codes, you're going to do a bend test, and then you're going to look at and see and make sure there's no openings or a crack or some kind of discontinuity that would be cause for rejection. Welder qualification, test requirements. I'm not going to go through this. This gives you a general idea of what the, acceptance criteria are for radiographic testing. You can't have any slag, elongated slag over certain lengths or group slags or whatever. Here's all the criteria. You can see it's fairly involved. each code has its own, like I said, a lot, and I keep preaching this. A lot of this welding stuff is you need to read the code. You need to read the code that you're working to. I don't memorize codes. I never did. I had a general familiarity with them, and then I know where to find stuff. But I didn't commit things to memory. My mind doesn't work like that. So I knew where to find it, but I wouldn't, have it just fine-tuned on what was acceptable and what wasn't. I would go and read the code or the specification every time. So anyways, here's a general idea of if you're going to use radiography to qualify your welders, here's the acceptance criteria for that process, that NDE process. Filler metal F numbers. This is a really important one because it's based on the usability characteristics, i.e. the ability of welders to make satisfactory welds with a given filler. So for our, let's go from F5 up. F5 is austenitic stainless steels and duplex stainless steels in the shielded metal arc stick form. Those things run completely different than stick welding, shielded metal arc welding with carbon steel. So they've got their own F number. Then when we get to carbon steels, we got F1, 2, 3, and 4. Well, F1 is all the flat position stuff, like 7024 or 7027 or whatever. Pick a number up there in the F1s. All that stuff's meant to run flat. You can't run that stuff overhill. So if a welder qualifies with that, that's all they can run. For the out of position stuff, F2, you've got let's say 7012 or 7013 or 7014 under F2. If I qualify with F2, I also get F1. Same for F3. Let's say I qualify with 6010, I could weld with 7012 and 7024. F3 qualifies me for F2 and F1. And if I qualify for F4, which is 7018, 8018, all the low hydrogens, the 15s and 7015, 7016 or whatever, I can go from there and I get F3, F2, and F1. And then you got these things down here. F6 is generally, unless you're doing TIG welding, gas tungsten arc welding, it's bare rods. So you could have F6 material being used as a gas tungsten arc welding or gas metal arc welding, but it's different processes. So the welder wouldn't be qualified. You do a TIG test, you don't get the gas metal arc certs, even though you're using the same F6. And then you have things like nickel alloys, titanium alloys. There's copper alloys. There's a whole host of F numbers. So the welder qualifies with that F number. You got to stay in your swim lane and weld only with that F number. Unless there's some provision in the codes that give you other ones. Like I said, if you qualify with F4, you get F3, F2, F1. You got to read the codes, though. The bottom line is you got to read the codes and be conversant in the codes. Welder performance qualification. Once a welder passes a test or a series of tests, their employer or third party will certify the ability to pass the test and the limitations or extent they are qualified to weld as a written document, a welder qualification test record or WPQR. This document is valid for a limited period after which the welder must be retested. Some qualifications are only valid for a single project, while others are unlimited as long as the welder do not go beyond a specific length of time without performance that specific welding type. This period is often 6 months. So this is where you get into keeping track of your welders and have they used we used to keep a log, a continuity log. So a welder would have to weld with a specific, let's say flux core. Every 6 months, I would need to see that welder weld with that welding process. If he leaves the company, he loses his certs. If he doesn't weld with that process within 6 months, he loses his certs. And I think we had everything set up to do it every 4 months so that even if I missed something, I would still, on my continuity log, I would still get it because it was every, 4 months. So we kept it a little shorter. But I would just write down that I had seen that. If I saw that guy using that process for the day, I'd write down on a piece of paper. We had a little piece of paper, and I'd write it down and say, yep, I saw him. And if a guy hadn't used a specific welding process for a period of time, sometimes we'd set it up and just set up one weld booth, and I'd make everybody go through there. All right, everybody goes in there and makes a 6-inch long weld so I can see you utilize that process and that you still have proficiency using that process. So, it's documentation. You have the welder tests. Once the guy passes that test, he's good. And then another one is, the other part of this is, it's only good for a limited amount of time. He's got to prove every now and then within 6 months that he still has proficiency to deposit sound weld metal using that welding process. Plate positions. Okay, this gets into our numbers with, our positions, 1F, 2F. So with the positions, 1 is for the flat position, 2 is for the horizontal position, 3 is for the vertical position, 4 is the overhead position, F is for fillet weld, G is for groove weld. So using this nomenclature, 4G would be an overhead plate test. Or 4G is an overhead welding position. Here's our pipe positions. We've got 1G rolled position, and then we've got 2G position, 6G, and 5G. With this, there isn't any really, the 1G rolled position is just flat welding. It's just 1G. 5G horizontal is, it's a difficult position because it's overhead, uphill, and flat. So 5G is a difficult position. 2G in the vertical position, this is just with pipe. It's the same as 2G plate. And then we've got the 6G, which is the granddaddy of them all. 6G pipe, you qualify on this, you get everything. If you qualify on 2G and 5G, that's the same as doing the 6G position. So when we talk about welding positions with pipe, this is the main ones we're talking about. Here we've got welding positions. Once again, another essential variable for welders. You can see with increasing difficulty, flat is the least difficult. Horizontal 2G is a little more difficult. Vertical up is more difficult. And then overhead, 4G. You'll notice the G's in here. Everybody talks about G's. 1G, 2G, 3G, 4G, 5G, 6G. This is what you've got. It means groove weld. So here's, gives you an idea of the welding positions and, as they're getting more difficult. So generally, if you qualify for something, you get the ones below it. Depending on the codes and how things are written, different codes have different criteria for what is more difficult. So, but generally, like if you qualify 3G, you'll get flat 1G. If you qualify overhead, you might get something else. Each code's different. You got to read them. I don't have them committed to memory. I got to look on the little chart every time. But generally, if you do 2, 3, or 4G, they'll give you 1G, which is flat. Sometimes you might just need fillet welders. So here's the fillet weld positions: 1F, 2F, 3F, 4F. You can see there's, different positions here. So when you're with, the thing to remember with fillets is you don't get groove weld qualifications with fillets. Groove weld qualifications will give you fillets, but fillets won't give you groove welds. Here's 2F and 5F with fillet welds, the 2 and the 5 position. Give you an idea. Pipe positions. 1 is for a pipe in a horizontal position that is rolled. 2 is for pipe that is in a fixed position. 5 is for pipe in a fixed horizontal position. 6 is for a pipe in a 45-degree fixed position. F is for fillet weld. G is for groove weld. So using that nomenclature, 6G is for a pipe in a 45-degree fixed position. So, yeah, it gets all back to, being able to speak the language of welders, and this is, part of the nomenclature and the language for being able to speak pipe positions, because, they gave them these numbering systems so that, you could talk back and forth. Okay, it's in this position, as opposed to, well, I had it at this, trying to describe it. No, it was at the vertical position. So this language is pretty much universal across all welding positions or welding codes in the United States, and anybody that uses our codes. I don't know how the Europeans do it, but this is our system.
Key terms and definitions. Essential variable. A parameter that when changed outside its permitted range requires requalification. Is any condition changed that could affect the quality and integrity of a weld deposit and would necessitate requalification. A non-essential variable is a parameter that when changed does not require requalification. Any condition changed that does not affect the quality and integrity of the weld deposit and does not necessitate requalification. This would be like, for example, if you qualified a weld procedure using 1/8 inch filler material and then you wanted to use 3/32 inch filler material. Some codes might require you to requalify, but for a lot of codes that would be a non-essential variable. You're just switching from 70/18 at 1/8 to 70/18 at 3/32. Like I said, some codes might require requalification, but for the most part that would be a non-essential variable. Procedure, the detailed elements with prescribed values or ranges of values of a process or method used to produce a specific result. Procedure qualification record, PQR. A document providing the actual welding variables used to produce an acceptable test weld and the results of tests conducted on the weld for the purpose of qualifying a welding procedure specification. Qualification, a demonstration of ability to meet certain prescribed standards. Supplementary essential variable is an essential variable only when impact testing is required. Welding Procedure Specification, WPS, a document providing in detail the required variables for a specific application to assure repeatability by properly trained welders and welding operators. A welding process, a materials joining process which produces coalescence of materials by heating them to a suitable temperature with or without the application of pressure or by the application of pressure alone, and with or without the use of filler metal.
Questions? You got any questions? Shoot me an email. You guys know how to track me down. I generally try and get back to people if you got a welding question or need clarification, or hey, if there's something I messed up on this presentation and I need to fine tune it on the next iteration, feel free to let me know where I messed up. Anyways, have a good day. Thanks. Bye.